Hello everyone and welcome to this science tutor video on graphing. In previous videos we discussed what a graph is, the essentials that a graph needs to have, and we also discussed some of the information that you can get from a graph. We ended talking about the best fit line, the line that is the best fit of your data. The best fit line can be straight or curved usually, but most graphs that you'll plot will be straight line graphs. Once you plotted your best fit line, you can determine the gradient of the line, or the slope of the line. The slope is just a measure of how much the quantity on your y-axis changes with the quantity on your x-axis. The general equation for gradient of a graph is that gradient is equal to delta y over delta x, or y2 minus y1, over x2 minus x1. So when plotting your graph, you use 2 points, which you know the x and y values for, and using the gradient formula you get a calculated value for the gradient or slope of your graph. Another piece of information you can get from a graph is the y-axis intercept. Now when you plot a straight line graph, in some cases the graph does not start from 0, So when you have your x and y data, the graph actually touches the y-axis at the point when x is equal to 0, right here. That value is referred to as the y-axis intercept, which is given the symbol c. C is just the value of y when x is equal to 0. So you might think of it as the starting value or the initial value of y. That is your y-axis intercept. Now the x and y values of any point along a straight line, along a linear graph, can be represented using what's called the equation of a straight line. Now the equation of a straight line states that y, the value of your parameter on your y-axis, at any point is equal to a constant, m, times the value of x at that same point, plus c. Y is your y-axis variable, x is your x-axis variable. We said that c is equal to the y-intercept, and this constant m is what we refer to as the gradient or slope of your graph. So the equation of a straight line says the value of y at any point is equal to the gradient times x plus whatever the value of the y-intercept of your graph is. Now the gradient can have different values. If your graph has a gradient of 1, then you have the exact proportionality between y and x. If your graph has a negative gradient, then a negative constant gradient, your graph will be a straight line, but it will slope downwards. So a negative gradient gives you a line like this. So two pieces of information you can get from a graph are the gradient and the y-intercept, which is given the symbol c. So let's move on to plotting an actual graph. We're given some information here that asks us to plot a graph of distance traveled versus time for the data below, and find the gradient and y-intercept for the data. We're also asked what these values mean. In this case, we are told to use a scale of 2 centimeters to 1 second on our x-axis, and 2 centimeters to 2 meters on the y-axis. Alright, so you can record the data. Alright, so you can pause the video and write on the data if you need to. Get a graph sheet and plot the graph along with us. So we're plotting our graph and we're told to use a scale of 2 centimeters to 1 unit on the x-axis, which means that every 2 centimeters we're going to go up by 1 second. Alright, so the first 2 centimeter mark is 1 second, then 2 seconds, 3, 4, 5, 6, 7, 8 seconds respectively. And we label our axis, time, and the units of seconds. Right. Along our y-axis, we're using a scale of 2 centimeters to 2 units. So the first 2 centimeter mark is 2 meters, then 4 meters, 6 meters, 8, 10, 12, and 14 meters. Along our y-axis, we have distance traveled. Right. So, based on the data that we have, let's plot our graph. The first point at 1 second goes right here. Alright. Y is 4, x is 1. Our second point, y is 6, and x is 2. So our point goes right here. For our third point, y is 8.4, and x is 3. Right? At that point, you have to find the location of on your graph paper. That will be about right here. For our next point, y is 10, and x is 4. So that one falls right here. For our next point, y is 11.6 meters, and x is equal to 5 seconds. So that point falls about right here. And for our last point, y is equal to 14 meters, and x is 6 seconds. That point falls right here. Alright? Your graph is expected to cover more than half of the space you're provided with, so please ensure that you use up as much of the usable space on the graph as you can. These are our points. We can draw our best fit line. Remember, the best fit line is the best average of all of the points on the graph. Alright? And our best fit line looks something like this. Notice we have 1 point slightly above the line, 1 point slightly beneath the line. All the rest of the points more or less fall along the best straight line. We include our title, and this is a graph of distance traveled versus time. And we also need to include our scale. On the x-axis, our scale is 2 centimeters to 1 second. On the y-axis, our scale is 2 centimeters to 2 meters, or 1 centimeter to 1 meter. Alright? Now, based on this data, we can calculate the gradient of the graph and the y-axis intercept. In our next video, we will calculate what the gradient of this graph is, and we'll find the intercept along the y-axis. Alright, so thanks for watching. Please stay tuned till the next video.